Hello, and welcome to assignment 7. In this assignment, we will be focusing on how the AVR-DB can detect if VDDIO2 falls below the minimum required voltage, which is about 1.6 volt. We will be using the DAC and the op-amp peripheral to create a second voltage supply in the same way as we did in assignment 6. The objective of this assignment is to understand how the AVR-DB can detect if the VDDIO2 falls below the minimum requirement, introduce an error to VDDIO2 by lowering the output of the second power supply, and to plot the measured VDDIO2 data to see how it falls and rises. For this assignment, we are assuming that you have made the same hardware modifications and fuse settings as what we showed in assignment 6. Let's look at the code needed to complete this assignment. First, we will take a look at the MVIO init. Here we can see that we are enabling the MVIO status interrupt. This means that we'll get an interrupt either when VDDIO2 falls below the minimum requirement or rises above the minimum requirement. And we can see that in the interrupt handler, we are of course clearing the flag, as you always have to do in the interrupt, and we are toggling the LED to show that VDDIO2 have either fallen below the minimum requirement or risen above it. If you take a look in the port B interrupt handler, we see that if the current VDDIO2 voltage is above the minimum requirement, we will put it under the minimum requirement, or if it is under the minimum requirement, we will put it back over, and this should create an interrupt. Other than that, the code is exactly as it was for assignment 6, which means that we are measuring VDDIO2, converting it to millivolts, and streaming the data over to the data visualizer. Let's flash the device and see how it looks in the data visualizer. As always, we start by loading the workspace, setting the baud rate, starting the user transmission, and selecting a source for the decoder, and then we start to show live data. For this assignment, we are also plotting the state of LED 0. So to do this, we have to press play on the debug GPIO. And we'll see that currently the LED is reading 0, and as it's active low, this means that the LED is lighting. But if I now press the button, we will see that the voltage falls below the minimum requirement, and the input to the LED goes high, which means that LED turns off. And if I press the button again, the LED turns on and the voltage goes back up over the minimum requirement. That's it for assignment 7. Thanks for watching.